class 11th, we are going to start the chapter 4, unit 2, kinematics. First of all, what is kinematic? Suppose I am saying that this is an object is moving in this direction with some velocity, say 5 meters per second. So you can ask me by which force it is moving. If we are not discussing about by which force it is moving, we are just discussing about that this is the object, it is moving with some velocity. So we will say this branch of mechanics is known as kinematics. The motion is described from here to here, but without considering any force which causes its motion. So this time we will say this belongs to the kinematics. Now next thing is the first topic, that is called frame of reference. Frame of reference you can consider like with respect to some position. Suppose you are standing on a platform and a train is moving in front of you. For you, the train was in motion. But suppose you are inside the train. At that time, you will say the train is stationary with respect to you. Why? This is all about frame of reference, means position from where you are observing. This, it is the point. So, suppose again you are on the earth, you are seeing an aeroplane. You are seeing an aeroplane flying overhead. For you, with respect to the earth, the plane was in motion. But suppose you are inside the plane, at that time the plane will be in rest. But again, one more point you must consider. That point is, if the plane is moving with a constant speed or a constant velocity, this one, like this, at this time you will say the change in velocity is 0. If the change in velocity is 0, acceleration is 0, at this time you will say this is inertial frame of reference. This is in inertial frame of reference. There are two type of frame of references. One is called inertial, second is called non-inertial. If the object is moving with the constant speed, because you have to compare, if the relative velocity is 0, if you are comparing your velocity and the plane velocity, it is moving with the constant speed, then the acceleration is 0, and at that time the frame from which you are observing is called inertial frame. And second, if the object is moving but either speed is increasing or decreasing, means there is accelerated motion. If there is accelerated motion, at that time you will say non-inertial frame. For example, suppose this in this frame where you are watching, if I am moving, suppose for you I am moving because you are comparing the distances from here to here. This distance tells you about am I moving or not. Second example, in this you will say that I was in motion, but actually I was standing. My video frame was moving, I was standing at my place. Just to bluff you, the objects were moving in opposite direction. In this, so these are called frame of reference, from where you are observing. If for you any object is moving with respect to you, with respect to earth, then you will say you are observing with inertial frame of reference. But if the object is accelerating, that will be non-inertial. Our next topic is concept of mass. We know that every object in this world possesses mass, because every object in this world which has mass and occupies space is called matter, and every object is a matter, means every object consists mass. But the topic here is of point mass. What is point mass? This is like if you say ऊंट के मुंह में जीरा or a drop in an ocean. So a drop in front of ocean is nothing. Same way, if any object has a very small mass compared to the other object which has very large mass, very huge mass, then you will say this smaller mass as a point mass or a point object. Suppose you are standing on a platform, in front of you there is a train. In comparison of train, you are point mass, and an ant in front of you, in comparison to you and the ant is a point mass. If I am comparing to you and the earth, for the earth you are point mass, but this earth will be a point mass with respect to the whole universe. Now the next topic is about motion and rest. For you, I am in rest. You are also, if you are watching this, you are in rest. But if you are watching me from outside the earth, so what you will observe, I am moving. Every object on earth is moving if you are going outside the earth. Means, again, this is all about the frame of reference. With respect to any object, if the other object with respect to any object is in rest, so both are in rest. So if you want to describe any object that either it is in motion or in rest, so you need a point of reference. Suppose you are saying that I am in rest. Same thing, because of the frame. In this frame I am having the equal distance, constant distance from the left, right, up and down, whatever the position of my image is constant. If suppose I'll say that I am moving here, the position is changing with reference to this background. So this background is your reference point. So on comparing that background, you will say either I am in rest or I am in motion. So finally, if any object is changing its position with respect to the surrounding, so that object is in motion. And if any object is not changing its position with respect to surrounding, so that object is in rest. Now after this rest and motion, rest is a very simple thing, that if the object is not changing its frame of reference, so it is in rest. But second thing about motion, motion can be of three types: one dimensional, two dimensional and three dimensional. So let's talk about the one dimensional. We have the three coordinates of any object to describe the position: x, y and z. If you want to describe the correct position of any object, you will describe about all the three coordinates, that x, y and z. Suppose out of these three, only one coordinate is changing. Suppose x axis or y axis or z axis, any one is changing. So at that time you will say the object has one dimensional motion. For example, a car moving on a road. So only suppose you can say x axis changing. So this is motion of one dimension. And if out of three, two coordinates are changing, at that time you will say the object is performing two-dimensional motion. For example, the motion of planets around the sun. And if all the three coordinates are changing, at that time you will say that motion is three-dimensional. For example, a flying kite. It moves up, it goes ahead, and if it is going up, so y and x axis and little bit z axis also. So the flying kite has three-dimensional motion. The next topic is about distance and displacement. To understand what is distance and displacement, just see here. Let an object initially at point A moving to the point B. The distance between A and B, I am considering that is 3 meters. So what is distance? Let's define the distance. The actual path is covered by any object is called distance. What is the path covered? 3 meters. So what is the distance covered? 3 meters. Very easy. A to B. Now suppose the person is going from B to C in this direction. So B to C, suppose there is 4 kilometer, the distance. So the total distance covered, how much? 3 plus 4. Total distance 7 kilometer. Now here the point, what is displacement? The definition for the displacement is the shortest distance from the initial point and the final point is called displacement. So from A to C, what will be the distance? Just draw. This is like a diagonal. It's performing the right angle triangle. One side 3, second side 4. Total becomes diagonal. By the Pythagoras theorem you will say 5 meter. So the A to C, the distance, not distance, displacement is 5 meter. So this describes about the distance and displacement. What is distance? The total path covered is called distance, and the shortest distance between the initial and the final position is known as displacement. So from A to C, if you are talking about the distance, 7 kilometer. And if you are talking about the displacement from A to C, you will say 5 meters and 7 meters. Now suppose the person again turning to the right and going to the point D. From A to now D. What is the distance covered? 3 plus 4 plus 3, how much? 10. Distance covered? 10. Displacement, again the shortest distance from A to D, how much? 4. The 4 meter is the displacement, shortest distance between initial and final. Now again the person is going back to the original position from A to B to C to D and then A. The total distance covered 3, 4, 3, 4. How much? 14 kilometer, 14 meter. This is the distance covered by the person. Distance, total path covered from A, and after taking one down, again point A, 14 kilometer. What about the displacement? There is no difference between the initial and the final position. Direct displacement, that is called. There is no change in initial and final position. The person is again on the same position from where it was started. He was started. So the displacement at this time is 0. So what we have observed, the distance always added up, because distance is a scalar quantity and displacement sometimes add, sometimes gets subtracted. So this is vector quantity. Vector quantity may be 0, positive or negative, while a scalar quantity is what you are seeing here, always positive, means in the counting numbers. Suppose from point A now, the person is moving in this direction, opposite direction, means suppose the point E. So what is the total distance? If I am talking that this is 1 meter. So 3, 4, 3, 4 and then 1 meter in this direction. So 14 plus 1, 15 meter. This is what? Distance. But what will be the displacement? When the person was going in this direction from A to B, we were considering displacement 3 meter, positive direction. And now the person is moving to the opposite direction. Then you will say minus 1 meter, initial and final. At this time you will say minus 1 meter, because the displacement is a vector quantity, so it may be 0, positive and negative also. But distance will be always value positive. So this is about the distance and displacement. Distance is a scalar quantity and displacement is a vector quantity. Next topic is speed. You have seen in the last diagram, the person was covering some distance, 3, 4 and something. If I am pointing the distance with some time, so in a unit time, whatever distance is covered by the person is called speed. In a unit time, whatever distance is covered by the person by any object is called speed. Let's see here. Suppose from point A to point B, as the person was covering distance 3 meter, and A to B, if it is covering 3 meter, I am considering that this has happened in 3 seconds. So In a unit second, how much distance is covered? In a unit second, unit meter means in 3 seconds 3 meter. So in 1 second 1 meter. So this is what? Speed. So in a unit second, the distance covered is called speed. The next topic is about velocity. As distance is a scalar, displacement is a vector. Same way, speed is a scalar and velocity is a vector quantity. So in place of this, if I'm talking about the displacement here, A to B, that was 3 meter. Distance and displacement both. In this case, distance and displacement both are of 3 meter because total path covered 3 meter. Difference between final and initial path is 3 meter. So displacement is also 3 meter. If I'm talking about the direction also, at this time, if you will say the velocity, so 3 meter upon 3 second is 1 meter per second. But at this time you have to inform that in which direction. Suppose this is a south direction, north direction. This one is the north direction. So you will say the velocity of the object is 1 meter per second towards north. This time you are describing about the direction also. That is why this is called vector quantity. If you are not understanding what is scalar and vector quantity, a very simple example. Suppose this room is completely dark. You are unable to see any person. And I am asking that find your friend who is 3 steps ahead. So 3 steps ahead. Ahead means I am giving you direction. And 3 steps means the magnitude. So magnitude plus direction makes a quantity vector. And suppose I will say your friend is only 3 steps away from you. 3 steps away. So you may go ahead, you may go back, you may go to right, you may go to the left. Means you can go to any direction to find your friend. Because of the improper information, you may and may not be find to your friend. Why? You are asking the direction. If I am saying only 3 steps, this is magnitude. But if I am saying the direction that 3 steps ahead or 3 steps right, then you can find your friend. Means this is our the magnitude 3 steps and the direction. With direction it is making vector quantity. So this is all about the scalar and vector quantity. Distance scalar, displacement vector, speed scalar, velocity vector. So whenever we are expressing the vector quantity, we have to give magnitude as well as direction. If I am talking about the velocity again, how to write? In class 9th you have seen the velocity is equal to change in displacement upon change in time. You can also say rate of change of displacement to the velocity. Here the delta, sign delta is called change in two values. Delta always signifies this triangular shape is called delta. This always describes about the change in value. This delta says about that the change is measurable very easily. But if the change is very fine, very small change, the change in such a way, the change in value in such a way, the change is about to 0. For example, if I am giving you a piece of biscuit, you can eat very easily. If I am dividing that piece of biscuit in 2 parts, then still you will accept. But if I am dividing that biscuit in a very small size, then you will say it's such a same thing. If the time which is in giving information about the change in displacement, I am dividing the time in a very fine value, very small value, such a way that this time is about to 0. At that time what you will write? The limit. Limit means the foundation about the time. The limit delta t is tending to 0. This arrow is called tending to 0. How to pronounce this? To pronunciate this, listen carefully. How you will pronunciate, how you will read this expression, you will say V is equal to limit delta t tending to 0. This arrow is known as tending to 0, means this change in time is very small in such that is tending to 0, almost covering to 0 but not 0, approaching to 0. So you will say limit delta t is tending to 0, delta s upon delta t. This means the change in time is very small. So it is very inconvenient to write up again and again limit delta t tending to 0 del s upon del t. So this is called calculus method. In the next step you can see v is equal to ds upon dt. That is called derivative. You will learn about it mathematics in the chapter 1 soon by the Puneet sir. So here I am telling about only the thing that v, which was that was delta s upon delta t initially up to your class 9, maybe up to 10th. But here in class 11 we are dividing the time in a very finite, very fine value. So you will write v is equal to limit delta t tending to 0 del s upon del t. Instead of that, simply what we can, v is equal to ds upon dt. This is called the s, displacement, is derivative of time. D, small d is known as derivative. So displacement is the derivative of time. If the displacement is the derivative of time, so that becomes velocity. So v is equal to ds upon dt. That you can also write. Here I am ending this session. In the next lecture we will discuss about the acceleration of a body and then different type of graph like displacement time, velocity time, acceleration time, and what we can calculate using that. So these all we will discuss about the next lecture. Till then, be safe, take care, and thank you.